Hello folks, welcome to this video on developing a causal loop diagram for the Paris air quality alternative exercise. And I'm going to use Vensim here, but I'm going to walk through on developing that causal loop diagram just so that people will have an example and so that you can follow through the thinking when we're developing these types of CLDs. So the first thing I'm going to do, I'm assuming that everyone's done the readings, and the readings were composed of a story or a case study written up by David Ford from Virginia Tech at this point. And there were some newspaper articles that he'd originally read and had gotten the idea from, and we've also provided you with those. And the idea is that you would read through that type of stuff, develop a problem statement, develop behavior over time graphs, and then develop a causal loop diagram. And this video is going over that causal loop diagram. So first thing I'm going to do is I'm going to go up and click on the variable. And I think I'll start with pollution. That seemed to be sort of the key thing that we were looking at here, or the key issue. I'm just going to type in pollution. My variable is still going to be selected, and I go down here a little bit to the left, and I'm going to just type in air quality. And I've picked these two variables because I believe, or I'm going to make the argument, that pollution is causing air quality to change. And what we are arguing is that causality, that one variable is causing another variable to change. And these variables both have a sense of going up or going down, right? Pollution could increase or it could decrease. Air quality could increase or decrease. So I'm picking variables that have this clear sense of increase or decrease. It's not necessarily that I have to have a numerical value for these, but that I do have a clear sense of increasing or decreasing. So I've clicked on the arrow. I'm going to left click. I'm using a mouse. I'm using a Mac. I'm going to left click once on pollution. I'm going to go here a little ways and click one more time. I'm going to go down to air quality. And this blue arrow is arguing that pollution, the tail, this would be the tail of the arrow, is causing the head air quality to change. And if pollution increases, I'm going to argue that air quality is going to go down. It will be worse than it would have been, all other things being held constant. And I'm going to click on the handle here, and now I'm going to right click on my mouse. It'll open this window up, and I'll go down to the polarity markings, and that will be a minus sign. I'm clicking on the minus. And once I've established this connection, and again, I'm always asking, if the tail increases, what happens to the head? And this is just to figure out what my polarity is. Once I figured out what my polarity is, pollution could go up or go down, and it would also influence quality. So if pollution went down, air quality would increase. It's moving in the opposite direction because of this minus sign. Next variable I'm going to add in here is the policy that was identified in the reading. And that was an odd, even vehicle policy enforcement. And the story was that the police would, or there would be a law that's passed that says, depending on your license plate number, that you would only be able to drive into the city of Paris if you had an odd number on certain days, and on other days, if you had the even number, you'd be able to drive. And this would reduce the amount of traffic in the city of Paris. So, and this policy is really, the level of enforcement is going to be a function, or is going to be caused by the air quality. So I've gone up and clicked on my arrow. I'm clicking on the air quality once, going halfway down, and then I'm going to my odd even policy. And again, I'm arguing that the air quality is going to influence the level of enforcement. And if air quality increased, there would be less need to actually do the enforcement. So I'm going to go to my handle. I'm going to right click on it. Again, it will open this window. I'm going to go to my polarity markings. And if the air quality increases, then the policy enforcement can move in the opposite direction. There's not as much need for it because air quality is pretty good. So this is going to be a negative sign and I've identified this link. The next thing I want to add in here, or the next variable, is daily vehicles in the city. Daily vehicles in the city. And if I am actually enforcing this rule, it will influence or cause the daily vehicles in the city to change. So I'm going to click on the odd even with the arrow selected, click once and go there. And if the odd even vehicle, if the policy enforcement increases, the daily vehicles in the city should decrease. So it's moving in the opposite direction. It will get a negative sign in this case. It's going to be a minus sign. I'll close this. And now I can see that the daily vehicles in the city is actually influencing their tailpipe emissions, stuff like that, is influencing the pollution. So I'm going to click once, click up, and go to pollution. And I've closed a feedback loop here, but I also have to ask, I'm arguing that daily vehicles in the city is causing pollution to change. So if daily vehicles in the city, again, that heuristic for figuring out what direction my connection is. If daily vehicles in the city increased, all other things being held constant, I would anticipate that pollution would also increase. This is going to be a plus sign. And now I can trace around this loop and determine if it is a balancing or a reinforcing loop, a positive or a negative loop. And there are two ways of doing this. One way is to identify if there are odd or even number of negative signs. And the rule of thumb is that if I have an odd number of negative signs, it's a balancing loop. So this is sort of the cheating way to do it. The other way is to walk around the loop, and you can pick any variable and have it move in a particular direction. And you would trace around to see if it comes back to move in the same or the opposite direction. So I can start with any variable and I can have it move in any direction. So for now I'm going to say daily vehicles in the city, I'm just going to have it arbitrarily increase. So if the daily vehicles in the city increased, the pollution, it's moving in the same direction, is going to increase. So when the pollution has increased, my air quality is moving in the opposite direction, so my air quality has just gone down. My air quality has just gone down, so the odd-even vehicle policy enforcement has just increased. And when the odd-even vehicle policy enforcement increases, the daily vehicles in the city has just decreased. And if you recall, I said, what happens if this increases originally? I've traced it around this feedback loop, and it's moving in the opposite direction. It's going down. The initial shock was up. It's traced around. It's moving down. That's the indication that this is a balancing feedback loop. And I'm going to go up to my comments and click on that. I'm going to click in the middle of this, and I'm just going to label this B1. And I'm going to go down, and where it says clear box, I'm going to click loop counterclockwise. I'm going to close this. I'm going to go to my hand, and this by default is pretty big. I'm just going to make it smaller. And I want to drag it down here. And there was one other variable I can add in for this story, and that was the Paris growth rate was in the article. And the idea of the city of Paris is growing over time. More and more people have vehicles. They're driving them more often. I'm going to click on the arrow. I'm going to have the link going. And if the Paris growth rate increased, all other things being held constant, my daily vehicles in the city would increase. This is going to be a plus. And another thing to notice here is that this variable is not, the Paris growth rate is not a function of any of the other variables I have in the model at this point in time. And if it remains that way, this is exogenous. It's outside of the boundary of the system for the most part. We're looking at the feedback loops and what they're doing. So I've developed one feedback loop. And typically in these complex systems, you're going to find more. And I think I can continue to tell this story based on the readings and add additional variables. So I've clicked on my variable up in the top left, And I'm going to add families with a second car was part of the story. Can't spell, but that's okay. Families with a second car. And it's this policy enforcement, the odd even vehicle policy enforcement, the story was saying, was causing people to purchase second cars. And if the odd even policy enforcement increases, families with a second car will also increase. So this is going to be a plus sign. So moving in the same direction. And then if people with a second car, and the idea with purchasing the second car is that you can get license plates that are different than what you have, so you'd be able to drive in that. You just switch cars and drive into the city. So I'm going to click on the arrow, and the families with the second car is going to cause the daily vehicles in the city to change. And if families with the second car, again, this is that heuristic. I'm always asking, if the tail increases, what happens to the head? The tail, families with the second car, increases. Daily vehicles in the city will move in the same direction. It's going to be a plus. And I'm good to go there. And clicking on the variable, and there was well, I've closed another feedback loop, so we should probably trace through that at this point. So we want to determine if this is a reinforcing or balancing feedback loop. And again, I can start anywhere. So let's say the daily vehicles in the city have just increased. My pollution has increased. With the pollution going up, my air quality is moving in the opposite direction. It has gone down. The air quality has gone down, so there's going to be more of this policy enforcement. Policy enforcement increases. The families with the second car increases, and daily vehicles in the city have increased. And I started out by saying daily vehicles in the city have increased. So when I trace this around, it indicates that it is a reinforcing feedback loop. And if I follow my rule, if there's an odd number of negative signs, it will be a balancing loop. I can see that there's an even number indicating a reinforcing loop. So I'm going to go up to my comments and click in here, and I'm going to call this R1. And I'm going to go, and this is counterclockwise. And the reason I'm picking the counterclockwise is because that's the direction the feedback loops are going. And when I'm adding these R1, these B1s, I want this curved arrow to be going the same direction as the feedback loop's going. I think it's just easier to follow, is the argument. And even here, we're not quite done yet. There are additional variables in the system. And one of the things the article was arguing for was that the second cars are creating more pollution. They're older, they're not as efficient, they're cheaper, so they're going to generate more pollution. So I'm going to add a variable in here, which is going to be the average pollution per vehicle. And I'm going to argue for now that it's really changing as a function or based on, it's being caused to change by my families with a second vehicle. And if families with a second vehicle increases, average pollution per vehicle, all other things being held constant, is also going to increase. So this will get a plus sign. I'm going to go down to the polarity markings, click on the plus. I'm okay there. And the average pollution per vehicle is going to influence the pollution. It's going to cause it to change. If the average pollution changes, then my pollution is going to change. And I will right-click on this. And if the average pollution changes, all other things being held constant, pollution will increase, so it's going to get a plus sign. And now I've closed one more feedback loop. In this case, I won't take the time to trace around. I know that there are two negative signs in this feedback loop so that it will be reinforcing. Go up to my comments, and I will put it up here. And this is going to be R2. And the direction is the same, so I'll make it a counterclockwise. And I will just adjust the size here. and put it in. So I've got 2 reinforcing loops and 1 balancing loop at this point. And one of the other things that were mentioned were sort of the attractiveness of mass transit. So I'm going to add an additional variable to my causal loop diagram. And in this case, I'm arguing that it's the air quality that's going to drive the attractiveness of mass transit. People are concerned about the air quality. So the air quality is going to come down and cause a change in the use of mass transit. And if the air quality increased, again, that heuristic for figuring out these causal connections, the direction of them, if air quality increases, my mass transit attractiveness and use is going to increase. Or actually, let's think about this. If the air quality increases, then the mass transit attractiveness and use will actually go down. So I'll click on this, and with the polarity markings, it's going to be minus. I'll click OK. And then the mass transit is actually, if we're using mass transit, there's probably going to be fewer second cars on here, right? So my mass transit is going to influence the cars. If mass transit attractiveness and use increased, families with the second car is going to go down. There's going to be another minus sign there. Move this up. It's going to move in the opposite direction. And what I've done with this is there are 2 feedback loops in here that I have just closed. And I'll go to the hand, and let's actually trace this around. For some reason, let's say that my mass transit attractiveness is increased. Families with a second car will then decrease. The daily vehicles in the city, the plus sign, it's going to also decrease. Pollution is moving in the same direction, will decrease. And then the air quality will actually move in the opposite direction. Air quality has just gone up. Air quality goes up. The attractiveness of mass transit, people are going to prefer to drive their cars or to purchase a second car in this case, so that the mass transit attractiveness is going to move in the opposite direction. So I've got another balancing feedback loop here. So let me put this in. I'm going to call this one, this should be B4. I'm going to keep it. I know that I haven't gone over the B3 feedback loop yet, but let me do this B4, and it should be moving in that same direction. So loop counterclockwise again, and I'll click on my hand and go in to adjust this. There's also the other feedback loop. Instead of running from family cars to daily vehicles, it's going to run along the outside here for average pollution per vehicle to pollution. And in this case, I'm just going to count the number of negative signs. I got 3 negative signs in that feedback loop. So this is going to be another balancing feedback loop. In this case, what I'm going to do is I'm just going to copy this B4, and then I'm going to hit a paste, and I am going to tell it to just replicate. And this is the one I wanted to call B3. Let's see, can I just, no, I'll go up to my comments and click on this, and I'm just going to relabel this B3. This will look like the diagram that you have in the answer. I'll go up to delete because I've added this comment and I don't want at this point. And let's see, am I missing, I think I'm going to add one more variable that was part of the story. And I'm going to click up here, and this was power plant output. And the argument is that if the air quality is going to influence the power plant output, so air quality increases, power plant output would move in the same direction. So if I have better air quality, I'm more willing to generate, or my power plants, I'm going to have more output from them. I'm willing to run them more. And I know that my power plant output is actually going to cause my pollution to change. And if my power plant output increased, then my pollution would also be changing. I'm going to put a plus sign. It's going to move in the same direction. I'll put a plus. You can see these plus signs are a little too close to each other. I'm going to go back and I'm going to right click on my handle again. And what I can do is I can click on this arrowhead on the outside, and I can see arrowhead on the inside, or it's on the inside of the arrowhead. So my plus sign has moved a little bit, so it's a bit clearer. I've added another feedback loop here. There's one minus sign, so this is another balancing feedback loop where they're not going to use the power plants as much because of the pollution. So I don't have a B2 in here, so I'll keep it. I'm going to go do the same thing. Click on the move. Just click on copy and paste. I'll tell it to replicate. And this will be my B2 feedback loop. And this is the story that we wanted to tell. Click on comments, go in and change this to a B2. And the other thing that I haven't done is these feedback loops should be labeled. Like B1 could be the, I believe it's the odd-even policy would be the label for these feedback loops. We want to have a label, and it could be a key. We could put these names in here as a comment, or we could have a key over on the side with the different feedback loops so that it allows us to tell the story better. And I'm just about ready to leave this. The one thing I want to do is, so my colleague, Dave Ford, developed this answer. He's the one who read the original articles, as I mentioned earlier, and developed this alternative assignment. And one of the things he had is he had an intervening variable. And what I'm going to do is I'm going to pull up the solution key, which you folks have. And you can see this is identical pretty much to what I had just run. But there's this cost of implementation of measures that Dave has added in. And when I was reading through this, I didn't quite see this in the same way. So I changed it, and I had my odd-even vehicle policy enforcement going to families with a second vehicle. So what I had was a little bit different. I'm just going to pull these. It's sort of hard to see, but let's see if we can do this. Let me go back and pull up the... So we can see if I can zoom in on my Adobe. Yes, and then we have these side by side. And what you should notice, and this will happen often, is that there's an intervening variable in here that isn't, it's not right or it's not wrong. When I was telling the story, the cost of implementation of measures was hard for me to explain. And it's not that it's right or wrong. When we looked at this and we complete these assignments, the feedback loops are actually identical is what it is. So the structure of the system is identical between these two exercises. The only difference is that there is an intervening variable. And I would argue that one isn't right and one isn't wrong. But when we're looking or we're reading these descriptions, when we're observing the real world and what's going on, we should be able to draw the feedback structure that, if not identical, is very, very similar. And that the idea that a colleague would put in these intervening variables means perhaps his story's a little richer than mine or better than mine, but because I was telling this, I needed it to be my story, right? I needed to be able to explain it to you, hopefully clearly. And that's what I have done. And the last thing I'll show you here, and I'm not going to go over, but is the importance of, there's a legend for the feedback loops that are here. And good practice is once we've identified these feedback loops, we can tell the stories. We should be able to relate these different feedback loops to the different behavior over time graphs that we have drawn, be able to tell the story that way. And we should be able to label these loops. And what Dave has done is he's labeled these loops, and then he's written a little description here to provide assistance when you're looking at what's going on. So this is sort of the story you should have learned about drawing these feedback loops. You should have maybe become a little bit more familiar with Vensim. You can do the same thing in Stella Architect or any of the other softwares that are available. And if you have questions, you should feel free to reach out to anyone teaching in the System Dynamics Introduction, the summer school. And we are here to help. And hopefully this makes sense. And thanks. And I will see you in class. Bye.